Okay, hi everyone. Hello. So today we will be solving previous year's assignment 4 for NPTEL course EE69 electromagnetic theory. Okay. So those who are joining for the first time, I am Vishakha Pandey. I am doing PhD I from electrical engineering. Um, Yeah, so let's start the session from IIT Bombay. I think I have repeated that again and again. All right. Okay, so let's start the session. Okay. So I hope you can see my screen. Arun, can you tell me if you
Yes, ma'am.
Yeah, okay. All right. For week 4, assignment 4, previous year's paper. So the first question is for 1 marks. So first question is direct integration method which solves Laplace equation is applicable only to problems which are first option one dimensional, second option two dimensional, third option three dimensional, fourth option none of these. Okay, so the question here says that if there is a Laplace equation given to us, then which dimensional equation can be solved using direct integration method? ओके सो क्वेश्चन बहुत ही सिंपल सा है. अगर हमें लाप्लास इक्वेशन को सॉल्व करना है डायरेक्ट इंटीग्रेशन मेथड को यूज करके, तो कौन सा डायमेंशनल प्रॉब्लम होगा, कितने डायमेंशन पे हम ये डायरेक्ट इंटीग्रेशन मेथड अप्लाई कर सकते हैं ताकि हम वो लाप्लास इक्वेशन को सॉल्व कर पाए. ये क्वेश्चन है. सो इज देयर समवन हु कैन टेल मी हाउ टू सॉल्व दिस क्वेश्चन? Just think about it. It's a simple direct integration method. How, if in a Laplace equation, if there will be more than one dimensions, then we won't be able to solve it using direct integration method, isn't it? We would be needing complex integration method. We cannot directly solve it using just a direct integration method, isn't it? So yeah. So let's say the Laplace equation is delta square f is equals to 0, isn't it? The Laplace equation is this. I hope all of you know that.
Yes, ma'am.
Okay, 1 second. It's ulta. Yeah. So this is a Laplace equation, isn't it? So Laplace delta square means del square x square plus del square y square upon del y square plus del square upon del z square. So a function f, let's say, is of x, y, and z. So for one dimension, this function will be, let's say, of x. Then for one dimension, Laplace of f, that Laplace equation for f will be delta square f, which will be equal to 0. That means delta square f upon del square f upon del x square is equals to 0. That means d square f upon dx square is equals to 0. So this will happen only if our function f is a function of x, only one dimensional. So the Laplace equation can be solved by integration on both the side with respect to x by direct integration method only when it is a function of x. Only x, when it's a function of only x, then only we will be able to solve it using direct integration method. So here, what will be the answer? Here, for direct integration method, which solves Laplace equation, is applicable only to problems one dimensional, isn't it? Hmm? Is there any problem, or should I go ahead? Okay. Okay, I will go ahead. So question number 2. So question number 2 is t is a function of x and capital T is equals to t1 at x is equals to x1, capital T is equals to 2. Okay, no one is here. Capital T is equals to T2 at x is equals to x2. Using this information to solve questions 2 and 4, the expression of T using the solution of Laplace equation is. Okay, so T here it is given that T is a function of x, alright, and at x is equals to x1, T is equals to T1, and at x is equals to x2, T is equals to T2, and now it is asked to us what will be the expression of T. सो हिंदी में बताती हूँ. हिंदी में ये बोल रहा है कि t एक फंक्शन है x का और x1 पॉइंट पर t1 हो जाता है, t की वैल्यू t1 हो जाती है कैपिटल T की, और x इज इक्वल्स टू x2 पर कैपिटल T की वैल्यू हो जाती है t2. अब हमें एक्सप्रेशन ऑफ t पता करना है यूजिंग द सॉल्यूशन ऑफ लाप्लास इक्वेशन. ठीक है. सो कैन समवन टेल मी हाउ टू सॉल्व दिस क्वेश्चन? Okay, no problem. Let's go. Okay, so function t is t equals to tx. It's given in the question. Given at x is equals to x1, will be equal to t at x1 is equals to t1. For x is equals to x2, t will be t of on at t at x2, that is equals to t2. So delta square t is equals to 0. This is the Laplace equation. So d square t upon dx square is equals to 0. This means d by dx dt by dx is equals to 0. Now let's integrate it here. If we put integration here, oh, it's not. Yeah, let's put integration here and here. Then what will happen? Integration of equation 1 with respect to x will be dt by dx. This will be removed, and integration for 0 will be for with respect to x will be c1. C1 here is a constant, isn't it? So then again let's do again integration of this equation. Then with respect to x, then it will become tx is equals to c1 of x plus c2. Again c2 here is a constant. Okay. Now to find c1 and c2, let's use the boundary condition. So boundary condition is already given to us that at x1 the value of t will be t1, and at x2 the value of capital T will be t2. So c1x plus c2 is equals to t1, c1x2 plus c2 is equals to t2, isn't it? So now to find out the value of c1, we will use this. We will subtract t1 from t2 and we will get this. So this will be the value of c1. Is there any problem till here? Any doubt till here? सिंपल देखो, सिंपल सा इंटीग्रेशन किया हुआ है. सिंपल पहले लैपलास इक्वेशन लिखा है टी का, कैपिटल टी का लैपलास इक्वेशन क्या होगा? डेल स्क्वायर टी इज इक्वल्स टू 0. उसको अगर हम x के टर्म्स में लिखेंगे तो डी स्क्वायर टी बाई डी एक्स स्क्वायर इक्वल्स टू 0, है ना. और उसके बाद क्या किया? उसके बाद इस इक्वेशन को लेकर के इंटीग्रेट किया गया है 2 बार. तो सिंपल 0 का जब इंटीग्रेशन करोगे dx विद रिस्पेक्ट टू dx, देन क्या हो जाएगा? एक कांस्टेंट होगा c1, isn't it? फिर उसको दोबारा से dt by dx को फिर से इंटीग्रेट करोगे तो क्या होगा वैल्यू? से किया तो फिर से इंटीग्रेट किया तो tx is equals to c1x plus c2. Both here c1 and c2 are constants. और and then we have put it boundary conditions को use किया है यहाँ पे t1 t2 को, and then t1 c1 की वैल्यू आ गई. Similarly, to find out the value of c2, we will put the value of c1 here. So c2 is equals to t1 minus c1 x1. Now putting the value of c1 from here, we will get the value of c2. Now putting all of this into the function of t of x is equals to t1 x minus x2 minus t2 x minus x1 upon x1 minus x2. So this will be your answer.
Hello, madam.
Ha. Yes. Go ahead.
Madam, that boundary conditions you are telling now how it is came, madam. Boundary condition means that E1 T which is equal to E2 T, that one only, no. Electric field
Yes.
tangential component is both are equal.
So this came from here. It is given in the question. So it is given in the question that at x is equals to x1, t is equals to t1. At x is equals to x2, t is equals to t2. It is given in the question.
I am asking, madam, to find out C1 and C2, you are taking no C1 X1 plus
Hmm.
C2 which is equal to
Yes.
T1.
Hmm.
How, madam?
So we are assuming here. See, you can take any constant. So this is unknown to us. C1 and C2 are unknown to us. Alright. So we are doing an integration. So you understood till here?
I know, madam, if your integrate means constant it will add, that one I
Yes.
know. Up to equation 2 I know. Na.
Ha.
Here only, madam, C1 X1 plus C2 which is equal to T1. How it is
Ha.
came, madam?
So see this equation you got. Now
Yes, madam. I
at
got idea
x1.
that one.
Okay. So see here, right, at x1. At x1 we have t1, right? So t1
Ah,
is equals to c1 and x plus c2 from equation 2.
okay,
Here,
madam.
here we have to write at x is equals to x1. So put the value of x is equals to x1. So this will be t1 is equals to c1 x1 plus c2. Got it? Here,
Okay, madam. Now
hmm,
clear, madam. Similarly, we are doing for X2 also. X
yes,
which is equal to X2.
yes.
Okay, madam.
Okay.
Sure. Yes, ma'am.
Hmm. All right. So is there any other problem you have? Then what we have after at x1 we got this, and at x2 we got this, and then we find out the value of c1. Similarly, we got the value of c2 and we put all of these and got the value of tx. Okay. Do you have any other doubt? No? Okay, let's go ahead. Now, in the question it is saying if t is equals to 0 at x is equals to 0 and capital T is equals to t naught at x is equals to t, then the expression of t will be. Now what you have to do here is put, yeah. Now at x is equals to 0, t is equals to 0, isn't it? So we can say that in this equation here we have a equation, right? So for x1, instead of x1 we can put x is equals to 0, and instead of putting t1 we can put t is equals to 0. Similarly, instead of at x is equals to d, t capital T equal to t naught. So instead of putting x2 in the equation we can put x is equals to d, and instead of putting t2 we can put t equal to t naught. Okay, and then tx will become, here we will put all these values in this equation, and we will get this minus T naught bracket in bracket x minus 0, and x1 is equals to 0, x2 is equals to d. So 0 minus d. So T of x will become T naught x upon d. Okay. तो यहाँ पे क्या करा है, x1 को x1 की जगह पे 0 डाला है, t1 की जगह पे t को भी 0 डाला है, x2 की जगह पे x इज इक्वल टू d डाला है, और t2 की जगह पे t इज इक्वल टू t नॉट डाला है. ठीक, तो हम इसको इक्वेशन में डाल देंगे फॉर्मूले में, हमारे फॉर्मूले में ही डायरेक्टली हमारा इक्वेशन आ जाएगा. दैट इज टी एक्स इज इक्वल टू माइनस टी नॉट एक्स, सॉरी प्लस टी नॉट एक्स अपॉन डी. ओके, डाउट हियर? No? Okay, let's go ahead. Huh. So if T is voltage is question number 3, then the electric field E is. Can anyone tell me how to solve? So voltage is given in question number 3. What will be the electric field E? How to solve this question? Okay. So if T is the voltage, then electric field will be equal to minus del T, isn't it? So E, electric field intensity will be equal to minus dt by dx x cap. So we will differentiate this and we will get minus T naught by d x cap. So electric field intensity will be minus T naught by d x cap. So that is option number D. This it was option number B. Okay. Now let's solve question number 5. Do you have any doubt till here? Question number 4? No? Okay. Let's go to question number 5. Which of the following equation represents Biot-Savart's law? Can someone tell me? Which of the following equation represents Biot-Savart law? For 2 marks.
Option A, madam.
Option A. How did you get to option A?
Why? Because we need to find out current carrying conductor. We need to find out magnetic field at any point. Means we need to consider small length of the conductor and the distance between that square of the distance between them. Then angle between that at the point and the conductor. Then how much current is flowing through that conductor. Why we are going to take sin theta means when that magnetic field, that observation point and the conductor both are at 90 degree means I will get maximum magnetic field.
Okay. Yes. Very good. What is your name?
Arun Raj, madam.
Arun Raj. Very good. Very good explanation as well. So what will be the option? Option A will be the answer. Okay. That's a good answer. Very good. Okay. So Biot-Savart's law is for a small magnetic field at point P due to a line element dl carrying current I will be given as dH is equals to mu naught upon 4 pi I dl cross r vector. R vector here is the distance vector upon r square. So dH will be mu naught upon 4 pi I dl sin phi upon r square. Okay. So this will be the answer. Yeah. Now let's go to question number 6. Okay. So which of these statements is not characteristic of a static magnetic field? So question is very simple. Here 4 statements are given to you and it is asking what is not a characteristic of a static magnetic field. So first option is it is solenoid. Second, it has no sinks or sources. Third is it is conservative. Fourth option is magnetic flux lines are always closed. So can someone tell me what what will be the answer here? How to solve this question?
But conservative field is related to electric field. I think option C.
Mm-hmm. Yeah.
Remaining solenoidal, that magnetic field flux, remaining thing is under related to magnetic field. Conservative field is related to electric field.
Hmm.
So I am thinking like that.
Okay. Very good. Very good. Arun Raj it is. Is it? Is it Arun Raj?
Yes, ma'am. Yes, ma'am.
Okay. Very good, Arun Raj. Okay. So for question number 6, a static magnetic field can produce a steady current since del cross B will be mu naught J. If we could write B vector as of phi, where phi is a scalar potential, isn't it? Then B would be conservative. But this does not happen, isn't it? This would imply that del cross B vector will be equal to del cross gradient of phi, which will be equal to 0. But this is clearly not the case. So static magnetic field is same because static magnetic field is non-conservative in nature. So this does not happen. So since this does not happen, then this means that static magnetic field will be non-conservative in nature. Other options that it is a solenoid. Yes, this can be a characteristic of a static magnetic field. It has no sinks or sources. Yes, correct. This is a characteristic of a static magnetic field, that it has no sinks or sources, and magnetic flux lines are always closed. Yes, true, magnetic flux lines are always closed, isn't it? It enters from one side and exits from one side, so it is always closed, magnetic flux line, for a static magnetic field, isn't it? So option C will be the correct option. Option C is the only option which is not a characteristic of static magnetic field. All right. Okay, let's go ahead. Question number 7. So question number 7 is two identical. This question is for 1 point. Huh. Two identical coaxial circular coils carry the same current I but in opposite directions. The magnitude of the magnetic field B at a point of the on the axis midway between the coils is. So here question is that two identical coaxial circular coils are given. Okay, and the current is same. Current is equals to I but in opposite directions. So two coaxial circular coils are given having same current but in opposite direction. So the magnitude of magnetic field at the point on the axis midway between the coils will be. This is the question. Can someone tell me what will be the answer?
Answer is zero, madam.
Yes, 0. Very
Why?
good.
Because we are having two conductor means, for example, we are giving one conductor 5 ampere means another conductor we are giving minus 5 milliampere. 5 ampere means we have to find out total magnetic field means B, which is equal to B1 plus B2. We are adding both means zero it will come.
Yes, very good. Yes. So here, okay, so two coils are given, circular coils are given. One has a current I, another has a current I but in opposite direction. So in opposite direction the another current is. So for one, the direction of magnetic field will be B1. For 2, the direction will be B2. But since it has a same but the circular coils are at same distance apart from point P. Okay, so let's say that B naught is the magnitude of the field due to either of the coils 1 and 2. Since both have current I but in opposite direction and are at the same distance D from point P, then field due to coil 1 will be B1 equal to minus B naught X cap, and field due to coil 2 will be B2 equals to plus B naught X cap. Okay, so total field will be equal to 1 field due to 1 coil 1 plus field due to coil 2, that is B1 plus B2, that will be equals to 0. All right, this will be our answer. B1 plus B2 is equals to 0. Okay, why? If they had, it had same current, it had, if it has same current and in same direction, then what would have happened?
Yes.
It would have went twice, but right now since it is in opposite direction, they will cancel each other and answer will be 0. Okay, very good. Okay, now let's go ahead. Question number 8. Advantage of method of images is, okay, so method of images, what is method of images? Hmm? What is method of images? No one? Okay, all right, let's go and check out the book. Okay, so for method of images is, in method of images, what happens is a point charge q is held at distance d above an infinite grounded conducting plate. Okay, and it is, if it is asked what will be the voltage, what will be the potential of it, so how you are going to find out the potential? So for this, it's a simple method is to make a image of the charge point q, that is plus q, and have a image of the same charge that, but in opposite sign, so that is minus q for from xy plane. Let's say the ground, if this infinite grounded conducting plane it is at xy plane, that is z is equals to, for z is equals to 0, then a image, to solve this question what we will do is we will make a image of the point charge in negative sign, that is minus q, and put it at the same distance apart, that is put it at d from the xy plane from z is equals to 0, and then try to find out the voltage. So the total voltage now will be v of x comma y comma z will be 1 upon 4 pi x, x 1 epsilon 1 upon 4 pi epsilon naught. So first for point charge q, so for point charge q it will be q upon x square plus y square plus, let's say we want it for, so let's say we want it for this point, we want it for this point. Okay, point p, so point p here is x comma y comma, from here it is z minus d. Okay, this is the origin, 0 comma 0 comma 0, and from this point it will be, one second, this is not, point p is, sorry, yeah, so point p is here x comma y comma z. Okay, but the distance vector will be x square plus y square plus z minus d, since the point charge here is at d. Okay, minus q upon x square plus y square plus z plus d whole square. Since from here it will be z plus d, the distance vector. So the whole potential will be equal to v x comma y comma z 1 upon 4 pi epsilon naught. So this is the method of images. So in method of images, what we do is for a point charge q and there is an infinitely grounded plane it given in the question and ask the potential, then we will put a image of at the same distance apart from the grounded plane and having the negative side, and then we will remove the grounded plane and directly find out the potential of the point from plus q charge and minus q charge, and that will be our answer. So this means that the advantage of method of images will be, first is it can solve problems without using Laplace and Poisson's equation. Yes, true, we don't need Laplace and Poisson's equation, isn't it? We are directly using the Coulomb's law. Then second is this method is done by replacing boundary surfaces with appropriate image charges. Yes, correct. By putting appropriate image charges we are getting this. Yes, this one is correct as well. The advantage of method of images is it is easy to approach. Yes, correct. So all of these. So our answer will be all of these, isn't it? Is there any problem you have in this question? No? Okay. Let's go ahead. Question number 9. Question number 9 is which of the following equation satisfies Laplace's equation? Okay. So Laplace equation is del square f is equals to 0, isn't it? This is our Laplace equation. So if we will put it here, here, then can we find out if it is satisfying Laplace equation? Hmm? Yes or no? So if we partially double differentiate equation 1, equation 2 and equation 3 and find out if it is equating to 0 or not, we will be able to find out if these equations are able to satisfy Laplace equation or not. So let's go ahead. Question number 9. So first is f is equals to x square plus y square minus 2z square. Now let's double differentiate it partially, then it will be 2 plus 2 minus 2 of z square, that is minus 4. Then 2 plus 2 minus 4 is equals to 0. Yes, it is satisfying the Laplace equation. Is there any doubt you have in this method?
Madam, if you are differentiating means 2x plus 2y minus 4 it will come, no?
Yes, it will be, see, if you differentiate for once, that is if we do this, then it will be, okay, 1 second now, is equals to 2x plus 2y minus 2 into 2 of z. Getting?
Yes, ma'am.
And
What
then,
about x, y, z?
yeah, and then again if we will do it, then 2
Okay.
plus 2 minus 2 into 2, that is 4.
Okay, madam. Double differentiation. Okay, madam. Correct.
Okay? Yeah. So this will be 0. Similarly, for question 2, again, del of f will become minus of 2x minus of 2 into 2 of y plus 3 into 2. So this, and then again we will, del of f will be become minus 2 minus 2 into 2 is minus 4 plus 6. this is equals to minus 6 plus 6 is equals to 0. So this is also satisfying Laplace equation. Understood?
Yes, ma'am. Clear.
Yeah. So for similarly here it will be del del of f is equals to 2x plus 2y plus 2z, and 6 minus 6 will be equal to 0, that is minus of 0. Then again differentiating it, that is f will be 2 plus 2 plus 2, so that is equals to 6. So it is not equal to 0, so it is not satisfying Laplace equation. So only equation 1 and 2 are satisfying Laplace equation, third one is not satisfying the Laplace equation. So option D will be the correct answer. A and B are satisfying, C is not. Okay. Question number 10. Laplacian is a composite operator that includes. Okay. So here this is equals to 0. So what we can write? We can write here as this. F. Let's take F. Can we write it as divergence dot gradient of F? Divergence dot gradient of F. So divergence of gradient of F. So here answer will be divergence and gradient operators. Both these operations are happening. So Laplacian is a composite vector that includes divergence and gradient operators. Okay. Is there any problem you have? Okay. This is for 1 point. All right. So is there any other problem you have?
Hello, madam.
Ha. Hello. Hi.
Madam, I have one doubt.
Mm-hmm.
I have one current carrying conductor. It having some current is flowing through the conductor. How to find out at a particular point how much magnetic field is there at
Yeah.
a particular point? For example, 3 comma 2 comma 1 Cartesian.
Ha.
I searched two books, madam. No formula is there. Uh,
Did you?
this is asked in assignment 4 only,
Ha.
but I cannot able to find out formulas. I searched the PDFs also I seen that I don't know how to find out. You are referring, madam, that book name is what, madam?
This book is, I have shared it with you all, but I will share it again to you. This book is Electrodynamic, Introduction to Electrodynamic by David J. Griffith. You can find out on Google as well. Just Google it, or I will put it on the folder. So can you access my material that I am sharing with you?
No, madam. Only I'm seeing YouTube only. That last three videos, YouTube
Oh,
only I am seeing, but.
okay, so see, you are supposed to get the materials that I am, all the assignment that I'm solving, and all the book or anything that I'm showing you, those should be accessed to you by, it should be given to you by NPTEL team. So if they are not giving you, then I have to make some arrangement for that, so that you can get. 1 second.
Just you have to show me that author name and title,
Ha,
madam. I will search in
David J.
college
Griffith.
libraries is available or not.
I am sharing my folder here so that you can get it. Okay,
Okay.
1 second. Yeah, so here I am putting it here on the chats. Okay, the link I am putting. 1 second, let me see if this is the right one. Ah, so Introduction to Electrodynamic is the book. Please access the from here. Okay, so NPTEL team is supposed to share all the material with you, all the solution that I'm sharing, or the assignment that I'm sharing with you. It should be shared with you, but if it is not, then you can get it from here. And about the question that you were asking, use Bio-Savart's law. using by using Bio-Savart's law, you will be able to solve the question. Okay.
Okay, thank you, madam.
Hmm. Is there any other question? Okay, so please access this link, and all the best for your assignment number 4. um, if you have any question, you can put it on the I don't know how you can communicate to me. You can communicate to me using that in a YouTube channel. There is a YouTube channel. You put your question there, you can communicate with me there by that. um, NPTEL team is supposed to share our contact details as well, but all right, they might not be sharing, but they should share the content that we are sharing here on the whatever we are teaching you. It should be shared with you. So save this link. Is this link I will be uploading all the content as well, so that you can get the content. Okay. And I can do one more thing. I can post it in my YouTube channel, this folders link. So this if I post it there, you can access from there as well. I will do that. Okay, so all the best. I think we are done for the session. For this session, all the best. Bye.
Thank you, ma'am.
You're welcome. Welcome. Bye.